Hello, students. Welcome to the end part of section 8.5. I'm going to go quickly through the rest of the notes so that you have it for Thursday. Again, I won't be in class. The expectation is that you guys will complete the rest of your notes and do all of the homework related to the notes. And then on Thursday, do quiz corrections, do your test review, and do the practice CCA that I made for you guys. I know it looks like a lot of work and probably is a lot of work, but it should fully prepare you for Monday. Let's push the CCA to Monday and the test. The test will be on Monday, so you'll do both on Monday. All right, so let's finish the rest of the lesson here. We made it all the way up until example 3. Let me just explain it a little bit more. Your airport is 1,007 feet above sea level, and your airplane is 2,714 feet above sea level. So the difference of the two is a total of 1,707 feet. Your airport is over here and your airplane's here. So we found the difference between the two. And what I do is I created a right triangle that appears to look like this. A 3-degree angle of descent or depression, and we also have 1,707 feet. We were looking for the distance. How many miles from the runway is the airplane? So we're not looking about horizontal distance. That would say something like, so this distance right here is horizontal. That would be how long until the plane is directly over the airport, right? That would be a horizontal distance. We are looking for direct distance, direct between the airplane and the airport. So we use sine of 3 equals opposite over hypotenuse, 1707 over x, and then we solved and we got 32,616 feet, and then we divide that by 5,280 feet because there are 5,280 feet in 1 mile, and we got 6.177 miles, so about 6.2 miles. Okay. Let's do it. An airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. So I'm going to draw the altitude as being 3 kilometers. 3 kilometers. And the airplane sees a raft at a 26-degree angle of depression. Be careful when you set up your right triangle. You can do an angle of depression. You would have to put the airplane over here. I know that I label this side as 3 kilometers, which is the same. It's equivalent. Both sides are 3 kilometers, but I'm trying to put the angle of depression in the right spot. So you could set it up like this. This is one method of setting it up. Let me change the color of there we go. So we have 3 kilometers, 26-degree angle of depression. I tend to draw like a little arrow. 26-degree angle of depression. What is the surface distance? It is from the raft, which is this distance right here. It means horizontal distance. Maybe a better way to draw this diagram, it's going to be equivalent values. But I will draw the same diagram over here so that you have two different depictions of it. Another way of drawing it would be to draw it like this. And draw our triangle this way. We're going to move the surface distance. That one's going to be this x right here. I'm going to put it here. Same thing. But you can't do your 26-degree angle of depression. See the issue? We can't do that. We could figure out what this angle is right here. It's 90 minus 26. Or, knowing what we know from before, the angle of depression is equivalent to the angle of elevation. So we could move this let me zoom in. Let's move this 26-degree angle over here and make it an angle of elevation. You have one or the other you can set up for. So call it its equivalent. Either way, you're solving for x. Notice in this one, 3 kilometers will then be the height of the plane. So this might be a better diagram. Angle of elevation is 26. Same thing as the angle of depression. And we are looking for its horizontal distance. Notice we are using tangent in this case. Notice for this one, we're still using tangent. It's still opposite over adjacent, still 3 over x. So it doesn't matter which diagram I use, but I'm going to say the tangent of 26 degrees equals 3 over x. And then we say x equals 3 divided by tangent of 26. If you need to take a step or two to get there, that's fine. I'm making the video short as possible, I should say. We get approximately 6.15. The distance from the raft, we're going to say distance is approximately 6.15. I'll change this variable to a d. That's fine. Distance is approximately 6.15 kilometers. That's it for that one. Surface distance. Okay, this one, an engineer is 980 feet from the base of a fountain at Fountain Hills. The angle of elevation, that's in Arizona. The angle of elevation to the top of the column of water is 29.7 degrees. The surveyor's angle measuring device is at the same level as the base of the fountain. The height of the column of water, find the height of the column of water to nearest 10 feet. So we are going to say that we are going to find the height of the water. So tangent of 29.7 degrees is equal to opposite over adjacent. So multiply both sides by 980, we get 980 times tangent of 29.7. We're going to have x is approximately 980 times tangent 29.7. Whoops, 980 times tangent 29.7. Make sure your calculator is in degree mode. We get x is approximately 558.98 feet. And it wants us to round to the nearest 10 feet. So that's this digit right here. So x approximately equals 560 feet. 560, so the answer is B. Okay, meteorology. The method that meteorologists could use to find the height of a layer of clouds above the ground is to shine a bright spotlight directly up onto the cloud layer and measure the angle of elevation. So here's another angle of elevation. We're looking for the height of the cloud layer. So another tangent. We're going to do tangent of 35 degrees equals opposite over adjacent in meters. I'm going to move this over. So x equals 525 times tangent of 35 degrees. X approximately equals 367.61. Find the height to the nearest 10 meters. To the nearest 10 meters, we're going to round it to 370 meters. It's about 370 meters high. Okay, but when you're going through these, ask yourselves, do the answers make sense? If I have a 35-degree angle there, I have a 55-degree angle there. So opposite the 35 should be shorter or less distance than opposite the 55. So the fact that I get 370 kind of makes sense. I don't know if it's perfectly accurate. If I was going through and checking my work, I would have to double check every step, but it seems to be appropriate. All right, the next one. A firefighter on the ground sees a fire break through the window near the top of a building. There's a voice contact between the ground and the firefighters on the roof. The angle of elevation to the window is 28 degrees. The angle um, the angle of elevation to the top of the building is 42 degrees. The firefighter is 75 feet from the building, so this is 75 feet. And the firefighter is 75 feet from the building, and her eyes are 5 feet above the ground. So this distance right here, these distances are 5 feet. So whatever I get, I just need to add 5 feet. I just need to remember to add 5 feet to it. So let's find the triangle without the 5 feet, and then let's add that on later on. What roof to window distance can she report to the firefighters on the roof? So what roof to window sill distance can she report? So we are looking for this distance right here. This is a very tough problem. We are looking for this distance right here. Okay, there is a lot going on in this problem. Why is the 5 feet there? The firefighter is 75 feet from the building and our eyes are 5 feet above the ground. Okay, we actually don't really need the 5 feet here. We're looking from the distance between the roof to the windowsill. So in that case, what I did in purple is all we really need. The 5 feet is just ambiguous. So let's do some algebra. We're going to have to first do the smaller triangle and then the larger triangle. So I'm going to call this x. So I'm going to say the tangent of 28 degrees equals x over 75. So x equals 75 times tangent of 28. 75 tangent of 28. And that is about 39.88 feet. So that is x. Now I need to solve for another variable. Let me say that y is the whole thing. There's no way to solve just for this little portion yet. I need to solve the whole length. I'm going to call the whole length y. Once I find y, I can take x away, and it will give me the rest of what's left over. So we're going to say the tangent of 42 degrees equals y over 75. So y equals 75 tangent of 42. So 75 tangent of 42. We get y approximately equals 67.53 feet. So the difference, let's call this z. I'm going to call that z. Z is going to be equal to y being the whole thing, take away x. So z is going to be equal to 67.53, take away x, which is 39.88. So 67, take away 39.88. I get Z approximately equals 27.65 feet. So the distance, what roof to window sill distance can she report to the firefighters on the roof? It's about 27.65. The 5 feet ended up not being necessary to use. So I'm just going to look up the answer key, make sure that it's all good. Geometry. And classwork. And we're in the textbook. We are, I know we're in chapter 8.5, but this is number 29. 8.5, number 29. And the answer is about 28 feet. About 28 feet. And we got about 27, we got 27.65, so we're right there. Let's say about 28 feet. We could also say about 28 feet. Okay. We could check our other answers if we wanted to. Meteorology is number 28. We got 370 meters, which is what they have as well. And then we have 560 for number 23. 560 for number 23, which is B. Which is B, is what we got. These are in the textbook, so I'd have to refer to the textbook to find those answer keys. All right. A 107-foot tall building casts a shadow of 90 feet. To nearest whole degree was the angle of elevation to the sun. So let's draw, we got a building. Draw a quick building. And that building casts a shadow. So here, let me draw like the sun over there. I'm just going to draw something quick. So here's that shadow. Let's put the sun up here. The building and the shadow. The building is 107 feet tall. The shadow is 90 feet long. This is not drawn to scale because if it were to be drawn to scale, let me draw a little bit better. If it were to be drawn to scale, 107 would look larger than 90, but it's not. We're going to say this is 90. Just take this diagram with a grain of salt. This one is 107 feet. Again, purple should be greater than the blue, but it is what it is. And the question is, what's the angle of elevation of the sun? That's this angle right here. So if you're standing on the ground and you're looking up, what angle of elevation is there? So tangent of theta equals 107 over 90, opposite over adjacent. So inverse tan of 107 over 90 is equivalent to theta. Switch your inputs and outputs. Inverse tan, type that right in, and we're going to get theta is approximately equal to, oops, let me try that again. Theta is approximately equal to 49.9 degrees. So we're going to say is approximately 50 degrees to the sun. Alrighty. 32. The angle of depression of a submarine from another Navy ship is 28 degrees. Okay, so the ship is above water. Here's my ship. Here's my sub. The angle of it says depression, so here's the submarine. I'm looking down towards the sub, and I have an angle of depression of 28 degrees. The submarine is 791 feet from the ship. About how deep is the submarine? So what's weird about this one is that when it says how deep is it, we know that this is going to be the depth of the submarine, that we don't know what that variable is. But the question is how the distance from the submarine. So it says the submarine is 791 feet from the ship. When it says that, it's talking about this distance right here. It doesn't say it if the ship traveled 791 feet, it would be above the sub. It says directly from one to the other, the shortest distance from one point to another is directly. So direct distance is from the sub ship to the sub. So I'm going to be using sine. So sine of 28 degrees is equal to opposite over hypotenuse. So x equals 791 sine of 28. 791 sine of 28 is x is approximately 371.35 feet. So it looks like it is 371 feet deep. All right. Let's do another one. A kite on a 100-foot string has an angle of elevation of 18 degrees. The hand holding the string is 4 feet from the ground. About how high above the ground is the kite? So we got a cool little, we're going to have a triangle, obviously. And the kite is on a 100-foot string. So if this is the kite up here, this is the string connecting it. I'm going to label this 100 feet. Be careful. We don't know how high above the ground it is, but we do know it's on a 100-foot string. We're going to put the person over here holding it. This person's holding the kite, the string that connects to the kite. And we want to know how high above the ground the kite is. We do know the angle of elevation is 18 degrees. So we have all the information we need. We're going to do sine of 18 degrees is equal to opposite over hypotenuse. So x equals 100 times sine of 18 degrees. And so x is approximately x is approximately 30.9 feet. We have to be careful of is that this information of it being 4 feet above the ground beforehand. So the person standing there is 4 feet tall, or at least their hand is 4 feet in the air. So you want to include that 4 feet right here. We're going to say that there's another 4 feet and another 4 feet, right? That person's standing 4 feet, so we have to make sure that we add that 4 feet in. So we're going to add 4 feet to this. So we're going to say plus 4, x approximately equals 34.9. And 34.9 is not an answer they offer because it's actually 35. We're going to round up to 35. So be careful. Don't pick the 31. You have to add the 4 feet in afterwards. So we get x approximately equals 35 feet. Okay. A 6-foot tall man is viewing the top of a tree with an angle of elevation of 83 degrees. That's a very tall tree. They're very close to it. He is standing 12 feet from the base of the tree. Draw a sketch of the situation. Show a stick figure for the man. Label the angle of elevation, the height of the man, the distance of the man, blah, blah, blah. Here is our tree. Perfect. A pine tree. We have a person looking, maybe that's too many pine. Okay. We have a person down here. They're looking up at the tree. We have an angle of elevation of, it said, 83 degrees. He's standing 12 feet away. The height of the man, we don't know, oh, 6 feet tall, I'm sorry, 6 feet. That is a very tall person. Here, this part is 6 feet. We'll have to add that in later. Write and solve an equation to find the height of the tree. So we're going to put an x here. I don't know what the height of the tree is. We're going to say that it is the tangent of 83 degrees is equivalent to opposite over adjacent. So x equals 12 tangent, 12 times tangent of 83 degrees. So x approximately equals 12 tangent 83, 97.73 feet, which seems reasonable for a tree. And then we're going to make sure that we add the 6 feet in. We're going to add 6 feet. We're going to get x approximately equals plus 6, 103.73. It wants it to the nearest foot, so we need to go a little bit further. We're going to say to the nearest foot that the tree is approximately 104 feet tall. Oops. 104 feet tall. Alrighty, this should help you. All of the rest of this is practice. It looks like a lot, but I want to put a little star right here near this one. This one's a great problem. You might want to focus in on that one. Try to get through the rest of these. A lot of the diagrams are labeled. Yeah, and all your answers should be in the book. The ones that we did, these won't be there, I think, because they're beyond the scope of our questions. But you have everything that you need. And I'll end this video